Good morning, everyone. Thank you for being here. Can I have the screen? Well, I'm inviting you today to speak about tear film as a mine of biomarker, and we try to make it easy, bridging research and theory with clinical practice. Let's go. Tear film or biomarkers in general are those defined characteristics that can be objectively measured as indicator of normal processes, pathogenical process, or as a response to an exposure or an intervention. There are many types of biomarker, molecular one like cholesterol, PSA, or in the eye MMP9, radiographic one like all images and in the eye mammography, histological one like biopsies, and physiological one like blood pressure or in the eye tear film osmolarity. And whatever the types, they can be used in all stages of our clinical practice, from early detection to disease monitoring, and it can help us deliver a tailored treatment based on the unique individual bioprofile so we can enhance treatment efficacy and reduce adverse effects. And that's what we call today the personalized medicine. The ideal biomarker needs to be easily measured, highly sensitive, giving us an idea about the classification of the disease and about the outcome or the response to treatments. And in fact, tear film can be an ideal biomarker because consider the ease of measurement of osmolarity, for example, the high sensitivity of MMP9 in both detecting and monitoring ocular surface inflammation, and also the help of many biomarkers like lipidomic biomarkers in the classification of dry eye disease into MGDs, for example. The history of those tear film biomarkers is not that recent. It starts in 1960 by the first discoveries. Then we discovered interesting molecule like MMP9, and we started hearing about personalized medicine in 2010. And today, with the help of genomic and artificial intelligence, we start using those biomarkers in disease monitoring, either ophthalmic disease or systemic disease. Well, let's focus now on the tear film biomarkers categories. We have physiological one, like tear film osmolarity, as we said, metabolic one, like lactate or lactoferrin, used in allergy and dry eye, genomic one, used in keratoconus, for example, proteomic, lipidomic one, like the one used in MGDs, or proteomic one, like MMP9 and collagen fragments, used respectively in inflammation and keratoconus. So what are today's key applications in ophthalmology? As you all know, we use them in dry eye and keratoconus, but we also can use them today in the monitoring of many diseases like glaucoma through the level of oxidative stress marker or diabetic retinopathy through the level of glucose in the tear film, advanced glycation ends product, or VEGF. And last but not least, we use them today in the classification and the monitoring of the wet form of AMD through the level of the complement factor H in the tear film. And if there are the two main conditions that has greatly benefited from those tear film biomarkers, they are undoubtedly the dry eye and the keratoconus. And here is a summary of the main biomarkers used in dry eye, for example. Inflammatory markers, cytokine and MMP9. They can give us an idea about the inflammation of the ocular surface. And here we will, as a clinical application, we will use an anti-inflammatory therapy. Osmolarity was greatly discussed by my friend Ashraf, so we will skip it. Lactoferrin can give us an idea about the tear film instability or guide us through a systemic disease like Sjogren that need to be treated. And if we want to assess the lipid deficiency, we can use lipidomic biomarker so we can treat the patient correctly with a lipid-based artificial tear. What about keratoconus? Once again, inflammatory markers, MMP9 and cytokine to have an idea about the progression of the disease. And here we'll go through an intensification of anti-inflammatory treatment, or we can perform an early cross-linking. Genomic biomarkers give us an idea about an early diagnosis, and we can here think about a preclinical cross-linking if we have more than a risk factor. And guess what? Today we can have an idea about a real-time destruction of the collagen in the tear film through the level of the collagen fragments in the tear film. And here we can think about an early cross-linking or redo a cross-linking to health progression if we still have collagen destruction in spite of the first cross-linking done. We can also adjust our treatment by adding some antioxidant therapy if we have a high level of oxidative stress protein in the tear film. And we can see how we can now today have an idea about the profile of patient and deliver a tailored treatment based on this. So let's have a closer look on how we can use those tear film biomarkers in our daily practice and what we can have in our hand to get benefit from this. Osmolarity can be assessed either by tear lab or IPIN. We can also assess the meibomian dysfunction by devices like LipiView, OZA. We can also detect the level of MMP9 by inflammadry, or use the tear scan microassay system to assess the level of lactoferrin and AGE used in allergy. Sometimes we can need further investigation, and we'll go through some laboratory-based analysis like mass spectrophotometry, PCR or ELISA, and multiplex assay. The list of the emerging application of ophthalmology is so long. I chose those main indications that seems important in my sense. Uveitis, we can today monitor uveitis to the level of cytokine in the tear film. Neurotrophic keratitis can be confirmed by the NGF in the tear film. We can also have an early diagnosis of ocular squamous, ocular surface squamous neoplasia to the level of some genomic biomarkers. We can also detect earlier corneal transplant rejection through the level of cytokines. And today, those tear film biomarkers are making waves beyond ophthalmology, and we are using them in many systemic diseases like neurodegenerative disease to the level of amyloid beta, oncology, breast cancer, lung cancer, infectious disease, metabolic disease, autoimmune disease, or even in cardiology through the level of natriuretic peptide. So here we can say that tear film are a real new era in ophthalmology. They can help us deliver a personalized medicine, but we need still a persistent research and bold collaboration to overcome some challenges. But for sure, they become a vital tool in both ocular and systemic health assessment. Today, we can say that in the smallest of tears, we can fight greatest insight into health. Thank you.